Hello, I am Prajit Poddar. I am presenting a paper. Uh, the paper is about effectiveness of ensemble machine learning algorithms in weather forecasting of Bangladesh. This paper has been accepted in 10th World Congress on Information and Communication Technologies 2020. I am from Institute of ICT, Bangladesh University of Engineering and Technology, Dhaka, Bangladesh. Okay. This is the outline of the presentation. Overview and introduction, main contribution, methodology, description of dataset, results and discussion, comparative analysis, conclusion. Machine learning is considered as a fundamental approach in predicting different phenomena, including weather. This paper focuses on the application of machine learning models in weather forecasting of Bangladesh. Whether where the weather changes frequently. The novelty of this work is in the application of ensemble machine learning regression algorithms to a raw dataset collected from Bangladesh Meteorological Division (BMD) for the year 2012 to 2018. The dataset has different attributes including wind speed, humidity, temperature, and rainfall collected at 33 weather stations across Bangladesh. The prediction is done using several machine learning based regression algorithms such as support vector machine, linear regression, Bayesian ridge, uh, gradient boosting, extreme gradient boosting, category boosting, adaptive boosting, um, K-nearest neighbor classifier, and decision tree regression. Our results show that the decision tree regression characteristics were brought from the algorithms supported in the literature in terms of mean squared error, mean absolute percentage error, and mean absolute error. Weather forecasting is supposed to be a prime factor of for Bangladesh economy as agriculture plays a vital role in the country's overall gross domestic product, which accounts for approximately 20% of the total amount. Nearly 70% of the total population lives in rural areas and 60% of them earn their livelihood from village staff. So the discrepancy of rainfall, humidity and wind speed, the temperature in time, space, and aggregation affects the country's agriculture, which might hamper the economy to a greater extent. Initially, meteorologists collect quantitative data mm, to assemble the forecast. Apart from its significant importance in agriculture and economy, successful forecast of rainfall and thunderstorm can save airlines from falling into accidents or in case of unwanted flight delays or unwanted crashes which may cause the death of many people. A number of a few types of data sources like satellite, marine, land-based stations, weather, balloons, radar, and phyloclimatic are available, and different sets of instruments are used to collect the data for measurement purposes. Intelligent weather prediction techniques can help us to a certain degree that can help us to make effective decisions that can save valuable lives, times, and property at a time. With the passage of time, science and technology have advanced to the next level, and weather pattern discovery has just attracted more attention. A number of research work has applied machine learning based regression models to predict the weather. However, only a few research works have reported the successful application of ensemble machine learning algorithms on a Bangladeshi weather dataset. This work focuses on this issue. The main contribution of this work are as follows. A Bangladeshi weather dataset having defined machine learning having different attributes including rainfall and temperature for the year 2012 to 2018 is split into training and testing portions. The data for the years 2012 to 2017 is used for training, while the data from the year 2018 is used for testing. Several machine learning algorithms are applied compared to the existing methods reported in the literature. Tradition, regression, and cat boost algorithms show better computational performance both in training and testing steps. The description of the dataset. The collected raw data set from BMD has been pre-processed and a lot of cleaning is required to convert it from a semi-structured dataset to a structured dataset and prepared for the implementation of our desired model. We have considered the data for the period of 2012 to 2018 as we want to obtain the possible suitable output for Bangladesh for the most recent weather data. After completing the pre-processing of the dataset, initially we have prepared two separate datasets in CSV file, one for 2012 to 2017 for training and testing the model and another one for 2018 to make the forecasting of rain where each dataset has four specific parameters including wind speed, rainfall, humidity and temperature, low and high. This is the methodology section. Initially, four weather parameters have been selected to forecast rain using this model. For those four parameters are rainfall, wind speed, um, humidity, and temperature. Eventually, the temperature is predicted splitting into two parts: high temperature and low temperature. Required processing is done to prepare the dataset. The missing values are repaired and the garbage values are removed by the preprocessing method. The proper algorithm is selected which is suitable for data. The data preprocessed data is split into two types: training the dataset and testing dataset. Then the model is trained with the training dataset and finally it is tested using the testing dataset. Usually, if it learns well from the training data, then it provides better output for testing data too. Output performance is observed comparing the performance of the model with the testing dataset. If its performance does deviate too much from the performance with the training data, then its performance is considered satisfactory. Otherwise, the model or algorithm needs to be changed. This is the statistical table on illustrates the statistical rainfall for rain is statistical analysis for rainfall for the year 2012 to 2017. Okay, uh, it mainly the values from the table on it is showed that the values of mean absolute error and mean square error measure based on the testing dataset, which indicates the learning efficiency of the machine learning models. From these measured values, we can notice that Adagos linear regression and Bayesian ridge showed much more error compared to other algorithms in the case of predicting rainfall. Table 2 is the statistical analysis of the rainfall in the case of forecasting for 2018 from the values of mean absolute error, mean absolute percentage error, and mean square error. It can be noticed that decision tree regression, short term DTR, performs exceedingly well in forecasting, so it is proved again that DTR plays a vital role in forecasting due to its structure and algorithms tree construction. Figure 2a and Figure 2b illustrate the rainfall forecasting performance of our used machine learning algorithms. Here, Figure 2a shows the monthly forecasting of rainfall for 2018 based on their previous experience from training and testing data. It clearly shows that Adabus does not show current performance along with other algorithms where SBR also lagged behind others in case of predicting the exit values. In the case of figure 2b, we can notice the daily basis annual rainfall forecasting by a chosen machine learning models. It illustrates the combined performance of each algorithm in case of forecasting rainfall daily of the year. Both figures demonstrate the forecasting performance of our machine learning based models where the efficiency of the machine learning algorithms is visibly noticed. The output shows quite similar performance in the case of predicting, which proves the stability of the machine learning models. Table 3 and Table 4 mainly illustrate the performance of the classic prediction algorithms. Machine learning, table 3 Table 4 mainly indicates the machine learning algorithms show optimal output in case of predicting high and low temperature. Table 3 set the standard for an initial dataset for testing data based on training data for high temperature, and table 4 showed the performance of the for the second dataset for forecasting high temperatures. In both cases, the values of mean absolute error, mean percentage error, and mean squared error are very negligible, which proved the authenticity of this approach of using machine learning based algorithms in the high and low temperature predicting. In a nutshell, it can be stated that machine learning algorithms provide an almost errorless prediction. Figure 3 and figure 4 mainly represents the monthly high temperature forecast of 2018, while figure 4 illustrates the high temperature forecast for each day of 2018. Table 5 and table 6 actually evaluate. Table 3 table 5 and table 6 mainly indicate the performance of for low temperature case. Actually, the mean absolute error, mean absolute percentage error, and mean square error values are also significantly less than the conventional methods, which promise an opportunistic approach for high and low temperature forecasting. All the algorithms used in our research showed sheer cohesiveness, which bolstered the claim of a most authentic high and low temperature forecasting technique. Similarly, we can obtain the monthly and daily high and low temperature forecasting observations from our developed machine learning models and compare them with the actual values which are preserved in the dataset of 2018. From the figures, it can be figure 5 depicts the figure 5 indicates the monthly low temperature forecast of 2018, and the figure 6 illustrates the low temperature forecast for each day of 2018. From figures, it can be stated that decision tree regression showed the best performance in improving errorless high temperature forecasting. Apart from DTR, linear regression version reach showed better performance compared to others. Okay, now I can this parameter conclude this paper. In this paper, we have applied ensemble machine learning algorithms to forecast the rainfall, low temperature and high temperature of Bangladesh. Our findings suggest that regression-based machine learning algorithms are capable of predicting weather events with a narrow margin of error rate, utilizing the smaller number of weather parameters. A number of algorithms are applied, and it is found that decision tree regression and cat boost methods have the best performance. However, the adaptability of decision tree regression as a point split nonlinear assumption makes it more ideal than Cat boost. The performance of a model depends on the dataset considered. Therefore, a number of other Bangladeshi datasets should be taken into consideration to validate the effectiveness of GTN and cat boost algorithms in future. Weather forecasting can be done for other features like humidity, wind, dew point, computing rainfall, rain, thunderstorm, rain, tornado, etc. in the context of Bangladesh. Thank you all.